Hello and welcome to everyone whoever is watching this tutorial. Today I would like to illustrate an example um, of solving a PV installation problem using Electrical Pro, which is pretty much ISPO, which I'm going to illustrate in just a few moments. First of all, let's get familiarized with the basic interface of this calculator. Okay, here we have these general arithmetic keys. Here the keys for the logical operation. These are the keys dedicated for electrical we can say units, and this for the wire size length that we will learn in a short while, and this is for setting the mode in which modes we are going to operate, different operating condition like one phase, three phase, different operating ambient temperature like 60 degrees Celsius and 5 degrees Celsius and so on. And these keys here are for storing the data in this key and restoring those values back. Okay, I would like to relate one practical example. Let's assume we have a solar PV system with a PV array of certain wattage inverter and a consumer at a certain point, okay, being fed through the inverter through or we can say in a certain AC voltage. Okay, in terms of figurative value, let's assume the problem is the PV system is of 1000 watts with the inverter rated at 1000 kVA for the full capacity, and the consumer is situated at around 1000 feet apart from the system. So we have to calculate the wire size required, the copper wire size required, and the voltage drop that's going to be applicable. So we are going to calculate those stuff using this calculator. Okay, we have rated capacity of inverter is 1000 volt ampere, and let's assume the voltage of operating voltage is 240. Full load capacity current we can calculate by the help of Kirchhoff's law here. Okay, first of all we are going to do that. We have 1001. Sorry. First of all, clear the screen. Okay, 1000 volt ampere, and we have volt. 240 is the volt. Then we can get ampere. That is 2.40 amps. Okay, now we have calculated the full load capacity current. Then let's calculate the copper size then. Okay, to calculate the copper size, let's set it to one phase. Okay, and then let's set the ambient temperature to 60 degrees Celsius. It's already 60 degrees Celsius here. Okay, and then next what we are going to do is we are going to set the copper type or aluminum type, which type of the copper or the conductor is going to be. For us it's copper, so we are going to assume that it's going to be copper. Okay, let's set the conductor type to copper. Okay, that is set. Now let's enter the kVA. For us the kVA is 1, isn't it? Okay, 1 kVA. Okay, done. 1 kVA, and for us the voltage is 240 is the volt. Okay, and then we will find the amps, that is 4.16. all right, and then we will find the wire size. Wire size is 14 AWG of the CO, so that is 14 AWG. Okay, now what of the voltage drop? What would be the voltage drop? Now to calculate the voltage drop calculation, we have to follow the similar set of stuff, but for the voltage drop it is now. So a little bit of modification of what we have learned. Let's get it started. Again, let's set it to one phase. It's already one phase, and let's say that ambient temperature this time to maybe 75 degrees Celsius, just for example, and the copper type or the conductor type is already in copper, so we don't have to change that. Now our full load capacity current 2.40, so we have to enter that. Let's enter that. That is 2.40. okay, 2.40, that is amps. Okay, amps. Now our voltage is still 240 volts. Okay, and then the length that is apart is, I think I have skipped one information here. So distance of consumer equal to 1000 feet. Okay, now we have 1000 is the length. Okay, 1000 feet. Now if we click the wire size, we can get the wire size of the copper is 10 cu and 10 HW of cu, and if we calculate the voltage drop, we'll get it 6 volt. Okay, it's 6.0 volt. That is, if we click again, we will get in percentage, that is 2.5 percentage. Okay, so in this way we can calculate the copper size and the voltage drop of this sort of renewable energy sources installation thing, feeding the consumers. This can be done extensively. This is just the example. We can use this example to many other large scale things. I think you got the idea. So thank you for following the tutorials, and good luck.